All right, we are going to look at just quickly what happens when a halogen bonds to a hydrocarbon. So, when a halogen bonds to a hydrocarbon, it's called an organic halide. So, an organic halide is a hydrocarbon chain with a halogen bonded to at least one carbon. So, just like when we are dealing with a side chain, we indicate position of the halogen use with a number, and we use a prefix to identify which halogen it is. So remember, our halogen is a group on the periodic table. So depending on which halogen atom is bonding to the hydrocarbon chain, these are our prefixes. So if it's a bromine, you use bromo. Chlorine, if it's chlorine, it's chloro. If it's an iodine, you use iota, and F is a fluoro. Okay, so we use a prefix to indicate which halogen is there and a number to indicate which carbon it is bonded to. So if we look at a couple examples, in our first example, we have an ethane. So it gets ethane, and then a bromine atom is bonded to one of the carbons. So this is bromoethane. Now, we don't have a number here because if the bromine, when the bromine bonds to this carbon, it's automatically carbon number 1. And so there's carbon 1 and carbon 2. And so we don't have to indicate that it's one bromo because we just assume it's there. If the bromine was on this carbon, this would be carbon number 1, and it would still just be bromoethane. Okay, but on this other example that we see right here, there's 3 carbons. So this is propane. It's all single bonds, so ane. And the bromine is on carbon number 2. So this is 2-bromopropane. Now, if you have more than 2, when you have multiple different halogens, so in this next example we look at, there's a bromine and a chlorine bonded to the hydrocarbon. We list them alphabetically. So bromo, B, comes first in the alphabet. And our numbers, we can see that we have 7 carbons in our chain, all single bonds, so it's heptane. Our bromine is on carbon 2, so 2-bromo, and carbon 4 has chlorine, so 4-chloro. So this is 2-bromo, 4-chloroheptane. So just make sure you've paused and you have this copied. Okay. All right. So you can also have examples where you have a halogen and an alkyl group bonded. So the rules for when you have a halogen and an alkyl group is that the halogen gets the lower number and the halogen comes first over the alkyl group in the name. So if we look at this example, missing this. Okay. So if you look at this example, we have 4 carbons. So we know that this is butane. But we can either number it starting from this carbon being carbon number 1. So 1, 2, 3, 4. Or it could have been 1, 2, 3, 4. The reason I am numbering with carbon 1 here is because that gives fluorine the position of the second carbon. If I numbered this carbon number 1, fluorine would be on carbon number 3. And our rule is the halogen gets the lower number. So our name is 2-fluoro because the halogen comes first in the name, 3-methyl because we have a methyl group on carbon 3, butane. Okay. So here's a more complicated example. This one has a lot going on. It's probably about as complicated as it can get, but I've color-coded all the parts to the naming. It's just applying all the rules that we know already. So we have 9 carbons, so it's nona, but there's 2 double bonds. I have to actually fix this name because I've used an old system that I did not teach you. All right, I'm going to fix this. It is not, it's going to be isopropo nona 2,5-diene. Okay, so this way that you see in color is an old method of naming. The method that we have talked about, I've written in black down here. So again, our halogens get preference in naming. So 8 iota, because there's an iodine on carbon 8, 5 isopropyl. And it's called isopropyl because it's a propyl group, but it's bonded to the middle carbon here. We'll talk more about that in your isomers task that you're going to look at. And then we already talked about the nona-2-diene. Okay, so in your assignment, I think you have 1 or 2 organic halides. So I just wanted to make sure you knew how to name those with numbers and prefixes. Organic halides are actually a pretty dangerous compound. Compounds, there's a whole bunch of them. A famous one is the chlorofluorocarbons, which are responsible for the hole in our ozone layer. Okay, so that is just a quick tutorial on what happens when a halogen bonds to a hydrocarbon.